Hey everyone, Mr. Schleicher here with another chemistry lesson. Today we're going to learn about pressure and temperature. I'm constantly trying to figure out just new ways to make these videos. If anything doesn't make sense or you're running into issues, please just contact me with that email on the screen right now, jason.schleicher at garlandisd.net, and I should be able to get back to you pretty quickly. Today's learning objectives are going to be defining what exactly temperature is, like using chemistry. And then we want to be able to describe this relationship between the temperature and pressure of a gas. So what is temperature here? We already know, degrees Fahrenheit, how hot is it outside? Degrees Celsius, if you're European or a chemist. We know how to convert and describe it with Kelvin as well. But what exactly is determining the temperature of a substance? Like what's going on that microscopic level? That's the answer. That's the question we're trying to answer here. Now, what is actually going on that very microscopic level is we have all of these tiny little particles of a substance. We know that, we have atoms, we have molecules, we have formula units. They're actually always vibrating or bouncing around randomly. And that movement that they have actually has a certain amount of energy, that kinetic energy of movement there. Some of these particles, they might be moving kind of slower. They have less kinetic energy. Some of them might be really fast with high kinetic energy. Some might be around the average. We have this huge range of kinetic energies here that determine this huge range of different speeds that determine the kinetic energy of all these particles. Now, if you were to take all of these individual particles and just take the average of the kinetic energies of all of them, that is what we call the temperature of something. So chemically, that definition of temperature is the average kinetic energy of a substance. Now you might be asking, okay, what does it mean if something feels hot to the touch or if something feels cold to the touch? Well, if something feels really hot to the touch, that means that substance that you're touching, whether it be like a hot pan or a hot chemical of some sort, its particles are moving around or vibrating very quickly. And when you touch it, the particles in your hand, all the molecules that make up your skin cells and stuff, they are being collided with those high energy particles. And that kinetic energy of the hot substance, of those hot particles, are bouncing into the particles in your hand and transferring that kinetic energy to your hand. The other way around, if you touch something cold, like an ice cube, for instance, the average kinetic energy in your hand, if you're touching an ice cube, is actually higher than the ice cube's kinetic energy. And whenever your hand particles are able to touch that ice cube, that actually transfers those high energy particles to the ice cube, making it feel cold because you're losing that kinetic energy. We'll talk more about all this thermal energy and heat transfer later on, but I just want to give you an idea of chemically what's going on there. So what we want to ask ourselves is, how does temperature relate to pressure when we're talking about gases? And we did say before that pressure was caused by all these gas particles actually physically colliding against something. Like these gas particles in the air, we can't see them right now, but they are always bouncing around, and just so many of them are bouncing around that we actually feel air pressure based off of that. Now, we want to ask ourselves these three questions. I just want you to come up with your best response here. If we increase a gas particle's kinetic energy, how would that affect the temperature of a gas particle, or the gas as a whole? If it had more kinetic energy, how would that affect how hard those gas particles collide with a surface or substance? And finally, depending on how you answered that, how would that affect the pressure of the gas? Try to answer those questions. Okay. So if you increase the gas particle's kinetic energy, that increases the temperature. That is what's going on here. Let's see. How would that affect how hard and how often those gas particles collide? If you have more kinetic energy, that means that your gas particles are moving around quicker and they will have more forceful collisions. But since they're moving around quicker, there's also more frequent collisions. So if you have gas particles that are hitting you more frequently, they're hitting you harder, then that actually means that there's more force in general, and that increases pressure. So That means that pressure increases when you increase the kinetic energy of a gas. Okay, a few example questions. A citizen accidentally leaves their water bottle in the freezer. What would happen to the pressure of the air inside of a water bottle if temperature of that water bottle decrease? Because it's in a freezer. And the answer here is pressure would decrease here. It might even decrease so much that the water bottle caves in a little bit. You might notice that in your day-to-day life. You can actually just take an empty water bottle, put it in a freezer right now, revisit it in a couple hours, you'll notice that it'll probably be a more caved-in water bottle. Okay, a pressurized air canister is thrown into a flame. What do you think will happen? Just make a prediction. And as someone who's actually done this, this can will probably explode. And the reason being is it's a pressurized can. The pressure inside that can that can already barely hold that pressure would increase due to the increase in temperature, probably causing some sort of explosion. That's why they say, whenever you have a bottle of hairspray, whenever you have some pressurized air to clean computers, do not put it in a flame or in an oven or wherever else it might accidentally heat up. Okay, a chemist depressurizes a glass container as part of an experiment. This actually happens a lot at the college level. What happens to the temperature inside the container as you depressurize that container? Okay, so now we're talking about changing pressure. So if pressure decreases, that means that temperature will also decrease here. Assuming that the container is the same volume, which, it's a glass container, it's not going to change its shape. So we'll see here that whenever pressure goes down, temperature goes down. When it goes up, temperature goes up. And then the other way around. If temperature goes up, pressure goes up. If temperature goes down, then pressure also goes down. And the last thing we gotta be able to do is describe this using a graph. So how does this look like on a graph? So generally you'll have temperature versus pressure or pressure versus temperature, and it should be a directly proportional relationship. So just exactly what I said before, when one goes up, the other goes up. When one goes down, the other one goes down. And on your graph, that usually means that you are going to draw a straight line from the origin. So just at the very corner of the graph, just straight line upwards. So here's an example of a graph that looks like that. The main thing I want you to point your eyes to here is this graph on the right. They did pressure versus temperature. And whenever we're working with gases, it's always best to use Kelvin as our temperature because it shows us this really nice relationship where you go from 0, 0, that means no pressure with no temperature, and then just straight line up. So as one increases, the other also increases, just like that.